How can a color you see not exist? The truth has a lot to do with and why we see colors. Without going into the science involved, we recognize colors by their wavelengths. Think of wavelengths as the difference in the speed at which the signals from a color reach our eyes. The wavelength of every color gets to our eyes at different speeds. Our eye captures this information and sends it to our brain, which then uses it to determine the color we're looking at. However, there's a lot of trickery involved. So here, without further ado, here are 10 colors that don't exist. Number 10, purple. What? Yeah, I have a friend whose favorite color is purple. Yeah, he ain't gonna like this one. So what's the difference between violet and purple? As it turns out, many people use the names interchangeably, even though they are two different colors. That is, if purple is a color. This is because purple, unlike violet, does not have its own wavelength. Instead, you need to mix the two colors or wavelengths together to get it. In this case, these colors or wavelengths are red and blue. However, the resultant color is not purple, but green and yellow. Now, this is the point where we need to understand how the human brain processes colors. Our eyes see only three colors: red, blue, and green. But it identifies other colors by mixing these colors together. In this case, our eye detects purple by combining red and blue together. The resulting color should be yellow-green, but our brain replaces the combo with purple. 9. Pink! We have disappointing news for all the pink lovers out there. Pink does not exist. Like purple, pink does not have its own wavelength, but we can see it because it emits the wavelength of the color red. So whenever you see anything pink, you are actually seeing red, making pink just another shade of red. And true to this, you can create pink from red, just as you would add white to blue to get light blue and white to green to get light green. You can also mix white to red to get light red, or pink as we call it. Number 8, magenta. We should clarify that pink and magenta are two different colors, even though people use their names interchangeably. Pink is light red, while magenta is tucked somewhere between red and violet. However, unlike pink, which uses the same wavelength as red, magenta does not have a wavelength, which means it does not exist. Yet magenta shows up on the color wheel and is one of the 4 primary colors used in painting alongside cyan, yellow, and black. What is happening? Sorry. Remember we said magenta is somewhere between red and violet. As it turns out, those are 2 colors at either end of the rainbow. Remember Roy G. Biv? Red, orange, yellow, green, blue, indigo, violet. And the brain gets a bit confused, trying to mix colors like these together so it does one of 2 things. The first is to produce a color midway between both, which would be green in this case. That is not a very good idea since our eyes can see green. So the brain does something else. It invents a new color. That color is magenta. Number 7, brown. What? Brown? Wait, what? If we asked you what color was closest to brown, you'd probably mention black, since both share a few similarities. But the reality is a bit different. Brown and black are miles apart. In fact, brown is closer to orange than it is black. Or let's just say brown is orange. Brown has a wavelength of around 600 nanometers, which puts it somewhere between red and yellow. Somewhere between red and yellow? Question mark? Isn't that where orange sits? Yes! In fact, orange's wavelength is between 585 and 620 nanometers, which means brown is just one of the many shades of orange. That is why you can make brown by adding any dark color to orange. Blue and violet will do, but black is best. Okay, speaking of which, number 6, black and white. Color is a product of light, and light consists of wavelengths. When light hits an object, the object absorbs some of the wavelength and reflects the rest. The reflected wavelength is what we call color. So when you see a red car, for instance, you know it's red because the paint on the core on the car absorbs the wavelengths of other colors but reflects that of red. But sometimes an object absorbs all the incoming wavelength and reflects nothing. In that case, we don't see any color at all, when they say the object is black. And when the opposite happens, we see a mixture of every light and color, which is white. So are black and white colors? No, they are not. We call them shades instead. That is, you mix them with other colors to allow that color to reflect or absorb more light, making the colors appear brighter or darker, as the case may be. And talking about black and white, the black and white we see around are not pure black and white. The whitest white still absorbs some color, while the blackest black does not reflect some light. We can only see pure white by looking at sunlight that has not passed through the Earth's or any other planet's atmosphere. For pure black, you would need to look inside a black hole. These two facts will become important in the next entry. Number 5, Vanta Black, which I love that color, even though it's not real. It's not real! Researchers are currently engaged in an unannounced race to invent a shade blacker than black. One of such shades is Vanta Black, which was in the news a few years ago for being the blackest black available. But that begs the question, can anything be blacker than black? The answer is no. Remember we said it is impossible to see pure black unless we look into a black hole. That is the problem here. The black we see on Earth does not absorb all the light reaching it. This means it is a bit brighter than it should be, which technically makes it a very dark gray. But we regard it as black since it is the darkest black we can create without overcomplicating things. So in reality, researchers are not trying to create a shade blacker than black, but are trying to create black as in the 100% black we would see in a black hole. Considering black as an absence of light, it is hard to recreate the shade from colors. Light or pigments, which is why researchers are trying to make it from materials that are not only black, but are capable of absorbing as much light as possible. That is why we cannot paint a vehicle in Vanta Black since it is not a color but a material. In this case of Vanta Black, the material is carbon nanotubes made from air. It is so delicate that researchers even avoid touching it because it would collapse and be destroyed in an instant. Number 4, silver. Is silver a color? Most people would say yes, but struggle to recreate it on a phone, computer, or even a real-life painting. So again, is silver a color? No. Silver is a metallic hue, which is a fancy way of describing the shiny appearance of elements like gold and silver. But that shine is not the result of color, but light bouncing off their surfaces. That is the problem. Silver has to give off a metallic shine in text and art, otherwise it's just a pale gray. This makes it impossible to recreate it for text or hand-painted art without mixing gray with silver or some other material ground into fine powder. In digital art, we may create silver by manipulating the light and shade around an object. So does manipulating the light around gray or adding a shiny metal to it turn it into a color? No, any color would become shiny if we mixed it with a fine shade powder. Shiny powder. Unless we figure out a way to recreate a shiny silver color from scratch without using shiny powders or manipulating light, silver will continue to be gray. Sorry, silver. Number 3, gold. If silver is gray, what is gold? Yellow. Like silver, it is impossible to recreate gold in text, art, or digital media without mixing yellow paint with some fine, shiny powder, or manipulating the shines and light around yellow. But things are a bit different with gold. You see, gold should have a silvery color, just like silver, which would have made gold another shade of gray. But gold is a shade of yellow. Why? Science. Albert Einstein's theory of special relativity is at work. Remember E equals mc squared? That is it. Like everything else, gold consists of atoms. But the electrons in those atoms are traveling so fast, they cannot move any faster. So the extra energy they gain increases their masses, the amount of matter they contain, instead of their speed. This results in the atoms absorbing the lower wavelengths, especially blue, and allowing us to see higher wavelengths, particularly yellow. Number 2, neon. Unlike what fashion sites want us to think, neon is not a color. For starters, the so-called neon is not a single color, but a category of super bright lights. It's also the name of a gas. See? Neon gas, which lent the color its name, is an orange-red chemical element that sits on the periodic table alongside gold, silver, oxygen, hydrogen, helium, and so on. Neon gas even brings to the same family as helium gas. Belongs to the same family as helium gas. To create the original orange-red neon color, you would need to pass the light through neon gas stored in a bulb or fluorescent, causing it to give off orange-red light. This begs the question, does passing light through a gas make the gas a color? Our problem with neon does not end there. As we mentioned, neon gas turns into light orange-red. This means you need a few other gases, or mixtures of different gases, which may or may not include neon, to get the other colors, which we call neon, even when they are not. This means neon light does not contain neon, and like the colors gold and silver, it is impossible to turn neon light into a color without some fake light effect. In one sentence, it is impossible to recreate neon in art, text, or fabric, since those things do not contain light. So what about those neon shirts and handbags on Amazon? They are just super bright colors and not neon. And number one is off-white. Over the past few years, we have witnessed the proliferation of off-white clothes, bags, shoes, and other fashion items. It's even made its way into the home decor. But what really is off-white, and is it a color? Well, if you made it this far in the video, you obviously know the answer is no. For clarification purposes, we should add that off-white, with a hyphen and capital W, is the trademark of a fashion brand. Off-white with no hyphen and a small w is the color we are talking about here. Okay? Off-white is not a color, but a category of colors that are so bright that they look like white. To create off-white, we mix lots of whites, shade, with small quantities of bright colors like yellow and brown. Remember, brown is orange. We call the resulting color off-white, but it is actually a very bright yellow, very bright brown or orange, and so on. It is not darkened white. Darkened white is gray. Anything else is a brighter version of the color added to white. Well, everybody, I want to thank you all for watching. If you did enjoy this video, hit the like button. And I just wanted to let you know that a couple of my videos, you will see me wearing this shirt. I do want to let you know that I do change my shirts. I've recorded the same videos in a single day. Bye.